Write the heading. Electric potential due to a point charge. Suppose we have a charge Q here at origin. Let's consider this point as origin. And we have a small charge at infinity. Electric potential is the amount of work done in moving the charge, unit positive charge, from infinity to a point P in the electrostatic field of given charge, right? This is how we find electric potential. And now we are moving this charge from infinity to some point P in the electrostatic field of given charge. And this point P is at a distance R from the source charge. Okay? We are moving this charge, small charge, from infinity to point P. Okay? So the amount of work done is equal to electrostatic potential energy. And when we divide this by the amount of charge which we are moving, we get electrostatic potential. So what we have to find is work done. We have to find work done to get this value. Yes? अच्छा, अब इसमें हम क्या करेंगे? This charge has to cover this much distance to reach at point P. It will start from infinity and ends at, stops at P. Okay, so we will consider an intermediate position. So let's say that at a particular point of time, this charge reaches at some point A. And this point A is at distance x from the source charge. Okay, this charge is moving in which direction? What is the direction of motion of the charge? This direction. This charge is moving in this direction. This is the direction of motion, and the direction of force is opposite to the direction of motion. Yes, force is acting in this direction because this charge is positive. We are taking this charge as positive and we are assuming this source charge as positive. So both the charges are like charges. So this is the direction of electrostatic force, repulsive. Okay, and this is the direction of motion of the charge. So at a particular point of time, charge reaches point A, and this point A is at a distance x from the source charge. And after some time, it covers a small displacement and reaches point B and covers a small displacement dx. Okay, so small amount of work will be done. Yes. So this small amount of work done is equal to this. Okay, clear? Now, if we are considering this charge as unit positive charge, if this charge Q is +1 coulomb, then force is equal to, force acting on this charge is equal to Q into vector E. This is equal to electric field intensity. And this is the electric field intensity of source charge. This is the electric field intensity of source charge. Any doubt? Clear? Okay. So we can write this as minus f dx because they both are acting in the opposite direction. F dx cos 180 degree होता है ना? तो cos 180 degree क्या है यहाँ पे? Cos 180 degree. So this is minus f dx. Yes. And this f is equal to E. F is equal to E, and what is E? KQ by R square. And in this particular position, when it is at a distance x, then distance is x. So we can write K 1/4 pi epsilon naught Q by x square dx. Okay. This is a small amount of work done. For small displacement, small amount of work will be done. Now we have to find total work done. Total work done is equal to Total work done is equal to? We will integrate this. So minus infinity to r 1 upon 4 pi epsilon naught q by x square dx. Okay. So minus 1 upon 4 pi epsilon naught is constant, and multiply by q infinity to r 1 by x square dx. And x and dx is, what is x and dx? Yes, xn plus 1 upon n plus 1 plus t. We'll be using this relation and we'll get minus q upon 4 pi epsilon naught minus 1 by x infinity to r. Okay, now put the values here. What will you get? 1 upon 4 pi epsilon naught q by. So this is the total work. And charge we are taking is unit positive charge. Okay. Okay. So if q is less than 0, then if q is less than 0 means q is negative. If q is negative, then v is also negative. Okay. V is negative. In this particular case, work done by external force is negative and work done by electrostatic force is positive. Okay. And if q is less than 0, then because we are taking this charge as unit positive. So this is positive, right? If q is less than 0, then force is attractive, electrostatic force is attractive, and force and displacement have the same direction. So we can write electrostatic potential. Electrostatic potential as V is equal to minus infinity to R or P to a point P. If you are moving a charge from infinity to a point P, vector E dot vector dl. Okay. Or we can write, if you are writing in terms of R, then we can write initial position, final position, vector E dot vector dl. Yes. And this is equal to work done in moving the charge from infinity to a point P. Or we can write this as electrostatic potential energy by Q. This is the relation. Okay. Okay. So this is the case when we are moving the charge from infinity to a point P. If we are moving a charge from infinity to a point P, then potential is negative line integral of vector E dot dl. Or if you are writing in terms of R, then we can write E dot dr. And this is equal to work done, because see, potential, electrostatic potential is work upon charge or electrostatic potential upon charge. This we have discussed a number of times. Okay, so this is the case when we are taking our initial position as P and initial position as infinity and final position as P for a charge. Okay, this is the field of source charge, and we are moving this Q charge from infinity to a point P. Right, infinity to a point P. Then we write electrostatic potential, right, like this. What if charge is moving from one position to another within the electric field of a given charge? Then if we say that we have another situation where this is the source charge and this is the field of source charge, and we have this small q charge already in the field of source charge. This charge is here and it is moving from some point A to another point B in the electrostatic field of given charge. Then we can find the potential difference. How do we find the potential difference? How do we find the potential difference? Batao. This is potential difference AB, or we can write this as final potential, electrostatic potential minus initial electrostatic potential. कैसे find करेंगे? If we consider the situation that initial suppose charge जो है वो infinity पे है, infinity से उसको जो अगर आप A पे लेके जाओगे, है ना, तो जो work done होगा, work done per unit charge, that's your VA. And if you move this charge from infinity to a point P, then जो work done होगा per unit charge, that's VB. And we can simply subtract these two to get the potential difference. ठीक है, आ रहा है समझ? ठीक है, तो ऐसे हम potential difference find करेंगे. And this potential difference is equal to work done in moving the charge from A to B divided by the charge. The charge जो हम move कर रहे हैं from A to B, that charge. Okay, so work done in moving the charge from A to B divided by Q. ठीक है? Or we can write this as negative integral A to B vector E dot dl. Now you can see limits have changed. है ना? पहले लिमिट क्या थी? Infinity to P. Because we were moving the charge from infinity to point P. Now we are moving the charge within the electrostatic field of given charge. So our initial position is not infinity, it is some point in the electric field of the given charge. And this is another point in the same field. So initial position is A and final position is B. Or if you are writing in terms of R, then we write minus integral RA to RB vector E dot dr. Okay. Okay. Or we can write, see this E is 1 upon 4 pi epsilon naught Q by R square into R cap. Okay. Yes. Let's not write in the vector form. Let's simply write this as KQ. This K is 1 upon 4 pi epsilon naught KQ, and we can write RA to RB 1 upon R square dr. This 1 upon R square is minus 1 by R. Put the limits RA to RB. Minus minus plus. What will we get? First we will write the upper limit to R, and then we'll write subtraction sign, and then we'll write the lower limit. So this is the final answer. So KQ by RB minus KQ by RA. This is what we are getting. KQ by RB. What is electrostatic potential? How do we write electrostatic potential? Electrostatic potential is KQ by R, right? If you are writing KQ by RB, what does it mean? It is the electrostatic potential at B. And if you are writing KQ by RA, what does it mean? This is the electrostatic potential at A. So this is nothing but electrostatic potential at B minus electrostatic potential at A. Okay. So can you define 1 volt? Because as we know that B is W by Q, right? So can you define 1 volt? What is 1 volt? Gaurika, can you answer?
One joule of work done in moving a unit charge.
Yes, 1 joule of work is done in moving a charge of 1 coulomb. अगर W भी 1 joule होगा and charge आपका 1 coulomb होगा, only then potential difference is 1 volt, right? So when 1 joule of work is done in moving a positive charge of 1 coulomb from one point to another against the electrostatic field of given charge, then it is 1 volt. And देखो, suppose we have a charge here. This is a source charge, okay? And this is this dotted circle represents the electric field of this source charge, okay? This is the electric field of source charge. So electric field is kq by r square r cap. Suppose we have a point P here, it is at a distance r. So electric field at this particular point P is this. This is how we find electric field. Okay, and we have a small charge here at infinity. And so work done is moving this charge from infinity to this point P is the work done, and this work done is equal to electrostatic potential energy. Okay, so if we have this charge, we are talking about the charge, not the amount of charge. Okay, then it is electrostatic potential energy. But if we say that we have a unit positive charge, then work done in bringing the unit positive charge from infinity to that point P, this work done is electrostatic potential. This is how we differentiate. So electrostatic potential is denoted by V, and this electrostatic potential energy is denoted by U. And we say that W is equal to, work done is equal to electrostatic potential energy, and electrostatic potential energy is equal to V into Q, or QV. Or we can write V is equal to W by Q or U by Q. This is how we write. This is, see, amount of work done per unit charge. Na? So when we take unit charge, when we consider unit charge, work done per unit charge, then it becomes electrostatic potential. If we say work done in bringing the charge from infinity to point P, then it is electrostatic potential energy. Force multiplied by displacement, right? Work done is force multiplied by displacement. So if we take small amount of work done in small displacement, then we write like this, vector F dot dl. And it is the dot product. Now basically it is a dot product, right? F dot L we can write vector in vector notation. And for small work done, we take small displacement, right? This F is nothing but QE, right? If we consider this force as electrostatic force, and this is the small amount of work done in moving the charge by the small displacement dl, then we can write this as Q naught vector E dot vector dl. Okay. So for unit positive charge, if the charge is unit positive, then we can write Q naught as 1. And one more thing, this we had discussed in the previous class as well. कि अगर आपका ये चार्ज है, ये अगर सपोज ये भी पॉजिटिव चार्ज है एंड दिस इज आल्सो पॉजिटिव चार्ज, और हम इस चार्ज को यहाँ मूव कर रहे हैं, तो जो फोर्स एक्ट होगा वो किस डायरेक्शन में एक्ट होगा? इस डायरेक्शन में. और डिस्प्लेसमेंट किस डायरेक्शन में होगा? अपोजिट डायरेक्शन. व्हाट इज द एंगल बिटवीन द फोर्स एंड द डिस्प्लेसमेंट? 180 डिग्री. तो ये नेगेटिव हो जाएगा, है ना? नेगेटिव हो जाएगा ना. तो वी कैन राइट दिस एज माइनस Q नॉट E dl. ठीक है, क्लियर? And Q naught is 1. Q naught is 1 because it is a unit positive charge. So for a unit positive charge, it is okay. So we can write this as minus E dl. If the charge is unit positive, then this work done is equal to electrostatic potential. If we are taking unit positive charge, for a unit positive charge, this work done is equal to electrostatic potential. Okay. For a unit positive charge, this work done is equal to electrostatic potential, and dV is equal to minus AdL. For unit, right? Unit positive है ना बेटा, +1 कूलम. ठीक है, easy. So if we have to find net work done and net potential, then how will we find? We will find it by simply integrating it, है ना? We will get work done, net work done, and it is equal to minus integration E dot dl. And now here we are moving the charge from infinity to some point in the electrostatic field. So this work done can be written as integral minus infinity to p e dot dl. It is the work done in moving a charge from infinity to a point in the field of source charge. Is the work done in bringing a charge q from infinity to a point in the field of source charge. Okay. Suppose we have a charge here, plus q charge here, and this is the field of this source charge. Okay. And we have a charge q placed at infinity. So amount of work done in moving this charge from here to some point P in the field of given charge. This work done is equal to electrostatic potential energy. Okay. Okay. So because this is a source charge and this is this circle, it represents the electric field of source charge. So we can write electric field of source charge as vector E, and it is equal to kq by, let the distance of this point from the charge is r, to kq by r square into r cap. This is how we can write electric field of source charge. And this, because of this electric field, because this charge, this test charge is in the field of source charge, so this small q charge will experience force, electrostatic force, right? So we can write electrostatic force vector F as q vector E. Okay. Okay, let's consider this as the initial position of the charge Q. Okay. And it moves from point A and reaches some point, let's say B. So B is the final position and A is the initial position. So we can write the position vectors. Okay, for A, let's take R1, vector R1 as the position vector, and this is the position vector of the charge when it is at point B. Okay, so this is vector R1. Vector R1 is the position vector of the charge when it was point A, it was at point A, but when it moves from A to B, it reaches point B, then R2 is the position vector of the charge. So we have to find work done, the net work done by the charge. Okay, how will we find work done? See, when we have something like this, then we consider an intermediate situation. So let's consider a point that the charge reaches at point P after some time. Okay, and then it covers a small displacement, and reaches point Q. Right? So for this small displacement, can we find the work done? Can we find the work done for this small displacement? How will you find the work done? अच्छा, ये मैंने आपको करवाया था ना ऐसे कुछ कि
फिगर बनाया था फिर ना
मौसम खराब हो गया था। देखो, इसमें देयर आर टू वेज। एक तो ये है कि अगर वो इफ वी द चार्ज इज कमिंग फ्रॉम इंफिनिटी एंड रीचिंग पॉइंट एट सम पॉइंट पी, so we take the intermediate position as dl. Okay, and we can also consider this distance if the charge is moving from A to B. We can take, okay, we have to find total work done in bringing the charge from A to B. We have to find total work done in bringing the charge from A to B. Okay, अब वो टोटल वर्क डन आप कैसे निकालोगे? तो हम क्या करेंगे, एक इंटरमीडिएट सिचुएशन कंसिडर करेंगे। ठीक है, इंटरमीडिएट सिचुएशन कैसे कंसिडर करेंगे? विल अज्यूम दैट इनिशियली सपोज जो चार्ज जो है इनिशियली ए पे है और वो अभी मूव किया है, ए से बी में पहुंच रहा है, रास्ते में वी विल टेक अ इंटरमीडिएट पोजीशन पी। ठीक है, अब वो बी पोजीशन पे आ गया, अब P से वो कहाँ जाएगा? टुवर्ड्स B. तो सपोज वो P से स्मॉल डिस्प्लेसमेंट कवर करता है एंड रीचेस पॉइंट Q. So for small displacement, small amount of work will be done. For small displacement, small amount of work will be done. So we can write vector F dot dl, or see F is QE, so minus QE dl cos theta. Any problem in this step? Because we have a dot product, right? And F is QE and dot product hai, so cos theta aega. And this dl cos theta is equal to dr, so we can write minus QE dr. Okay. Now we will find total work done. Total work done in bringing the charge from A to B. So we can find net work done, total work done. How do we find total work done when small work done is given? See कैसे करते हैं हम? देखो, अगर हमारे पास सपोज कोई हम कुछ सिचुएशन कंसिडर कर रहे हैं कि जिसमें हम यहाँ से यहाँ मूव कर रहे हैं, ठीक है? तो फिजिक्स में हम क्या करते हैं, हम ना तो इनिशियल पोजीशन कंसिडर करते हैं, ना हम फाइनल पोजीशन कंसिडर करते हैं. वी कंसिडर एन इंटरमीडिएट पोजीशन. सपोज द ऑब्जेक्ट और द पर्सन और एनीथिंग, जिसका भी मोशन हम कंसिडर कर रहे हैं, वो पॉइंट सी पे पहुंचा और सी पॉइंट से वो डी पे पहुंचा, उसने स्मॉल डिस्प्लेसमेंट कवर किया, स्मॉल टाइम में स्मॉल वर्क डन हुआ, एंड दिस इज हाउ वी डू. एंड देन later first we differentiate and then we integrate. This is what we do. First we divide the situation into small parts and then we integrate all the parts to get the whole. Okay, so here also we are dividing the situation into parts. So we can easily find small work done for small displacement which is done in small time. Then we can find net work done, and net work done we can find by integrating all the dw's. ठीक है ना? So if we have dw here, dw here, dw here, so small amount of work done when added gives the net work done or total work done, we can say. ठीक है? Clear? So first we differentiate and then we integrate. So first we have found out the small displacement, and now we will find the total small work done, and now we will find the total work done. And total work done is integration of dw. Okay, and this dw is minus QE dr. So you can see in this expression we have dr, function of displacement है ना, यहाँ पे dr आ गया. Okay, so we will integrate this from, because this charge has started its journey from R1 and the final destination is at a distance vector R2. Okay, so initial position, final position, this is how we write. We'll give the limits to this integration. Now we can solve. Okay, so net work done will be, net work done is minus Q, and for this E is KQ by R square. Okay, so we can write R1 to R2. Here we'll write KQ by R square dr. See, we have dr here and this R square here. Okay, so K and Q, they are constant. So we can write them outside this integration. And in this integration, we'll have 1 upon R square dr. Okay. अब क्या करेंगे बताओ? कौन सा फॉर्मूला लगेगा इंटीग्रेशन का? It is minus K Q Q, and this is minus 1 by R, R1 to R2. Which formula we have applied here? X and dx. X and dx is xn plus 1 upon n plus 1 plus, yes, minus minus plus K Q Q 1 by R2 minus 1 by R. What is K? It is 1 upon 4 pi epsilon naught. Okay. Now write the final expression. Work done in moving the charge from A to B in the electrostatic field of given charge is equal to 1 upon 4 pi epsilon naught source charge, given charge, final position is R2, initial position of the charge is R. So this is the final expression. Close this in box. Okay. Any doubt?